In this section, we will discuss the importance of relational databases and why we use them. The PowerPoints provided are organized by Dr. Farouk Alami and narrated by Farhat Fazalyar. This video describes how relational databases work. In a relational databases, data are kept in multiple tables, which are related to each other using common fields. We demonstrate the concept through two tables of data, one about doctors, the other about patients. Then a visit table may list patients' visits to one of the doctor. Imagine a table of data that holds patient information. We want to use these lists to describe events that involve both doctors and patients. For the patients, we might have information such as patient ID, patient name, and what operating system they are using. The table may contain other information as well, but for simplicity, let's say with these three fields of information about the patients. For the doctors, we can have a doctor's ID, and doctor's operating system. There may be other information as well, but let's keep this simple and assume that we just have these three pieces of information. If we look at the patient's table, we might have a table that looks something like this. There are three fields: patient ID, the patient name, and the operating system they are using. The first row of data shows patient 1001, who is John Snow and who uses Mac operating system. Patient 1002 is Carol Allen, who uses IRIX as an operating system. The table contains information on other patients. Here we are showing patients 1003 and 1004. If we're trying to refer to one of these patient records, two patients may have the same name or use the same operating system. The only field that shows a unique patient is the patient ID field. There are no duplicates allowed in the patient ID field. A field that is uniquely identifies all entries in the table is also called primary key. Every table provides information about the records identified by its primary key. Let us also imagine some data in the table about the doctors. This table includes the doctor's ID, name, and operating system. In the first row of data, we have Dr. 2004. His name is David Gordon and he is using Windows operating system. In the second row, we have Dr. 2006. His name is Nicola Pipa and he is using IRX operating system. Each row describes a different doctor. The primary key is the field doctor's ID. All of the information in this table is about unique cases reported in each row. To describe a patient's visit to a doctor, we set up a third table called the visit table. We need to show that a particular patient visited by a particular doctor. We can do this by just using the primary key of each of the two tables. Once we know the IDs, we can look up the remaining information with no problem in each of the relevant tables. In the first row of this table, we are showing that patient 1001 was seen by Dr. 2004. In subsequent rows, we show that who various patients are seeing. Here, for example, we show that patient 1004 is also seen by Dr. 2004. You can go ahead and add as many visits as you want to the visit table. It often grows to thousands or millions of visits. Yet none of the information on patient or doctor tables are duplicated in the visit table, so the table is compact and efficient. This makes a world of difference in data analysis. Patient and doctor tables remain small even though the visit table may be massive. None of the information on patient or doctor tables are duplicated in the visit table, so the visit table is compact and efficient. The visit table has the minimum amount of information. Only information that changes from visit to visit is recorded in the visit table. The rest of the information that does not change from visit to visit are kept in auxiliary tables. This makes a world of difference in data storage and analysis. Massive but compact databases are organized using multiple tables and relationships among these tables.